Hi, this is a video showing an example of using the profiling function called profvis, profile visualization, in the R language. I'm going to talk to you just very briefly about what this code is doing. I'm simulating an oceanographic mooring that's being knocked over sort of imagine you have a helium balloon and a little bit of dental floss, and you're holding it, and the helium balloon, if there's no wind, will be straight above, and the dental floss will be below. But if there's a wind, the helium balloon will go over a bit to the side, and the floss will angle over, etc. And of course, if there's an angle and if the floss doesn't stretch, then the location of the helium balloon will move downward. In a really strong wind, it might be almost parallel with your hand. This phenomenon is called knockdown in an oceanographic mooring, and we want to make measurements in a mooring at particular depths. So we don't like knockdown, and we do things like we put floats, strong floats in the moorings which have a lot of buoyancy pulling it up. Okay, that's what this package does. So what I'm doing here in these lines, I'll just maybe run the lines. Running that line, so I'm asking for the library. And I've just created a mooring here with a default anchor, 180 meters of wire. Think of that as rope, but it's steel wire. And then a float, and I'm doing this in a water depth of 200 meters. And what I'm doing in this line is I'm creating a function U1. It's a function of depth, and that varies from, notice it's water depth of 200, so 200 minus the depth. That function then varies from 1 meter a second in the horizontal at the surface down to zero, linearly down to 0 meters a second at 200 meters at the bottom of the water. And this commented outline, what I've done there is I've just run the knockdown and I've done system time, and it's slow, and I want to figure out how to make it faster. But there's something that's going on in the knockdown code at the moment. Don't know what it is that's causing it to be slow, but I'm showing you the old approach first. So I've run it, what is it? 1, 2, 3, 4, 5, 6. I've run it a bunch of times, and I'm storing those times in this thing, and we'll just do this. I'm computing the mean of that, and this is twice can you see this part here is the standard error? It's the standard deviation, that's SDNR, divided by the square root of the number of entries, whatever, that I'm averaging. So that's what that is. And so I'll spit that out. And the answer that you get is it's a 4.9 plus or minus 0.05. That's what I'm getting from that. And it's pretty slow. Now, you would always want to do this. You would always want to do more than one trial. I mean, partly, maybe the first trial involves bringing up a library or something that doesn't happen later. Okay, but this is crude. It just tells me how long it takes to do this particular simulation. And but it's slower than I want. I want to see if I can make it faster. So I'm going to use the profvis function library and the function in it called profvis. And so let me do that. Run the library, and now this will take a little more than that 5 seconds that I told you it takes. Not much more. Okay, so we're done with that. And this is complicated. It's showing a lot of stuff. I'm scrolling through it here. A lot of stuff there. You can look at a flame graph, which is what I'm doing, and you can look at the data, which I don't want to do. So I'm going to show you the flame graph thing. Now, what it's showing in the top, I wonder if I don't really want that part anymore. Okay, so what it's showing in the top is the code. I'm in R knockdown. Yep, that's the code that it's running. And all this stuff is Roxygen comments on, if you can realize that, if you're familiar with R. And over here on the right, the first vertical line will be some measure of memory in some unit, and the second one will be some measure of time in some unit. And if you do question mark profvis, you can figure what those units are. I'm just going to scroll until I see something near those lines. Okay, there we go. So it's taking see the little like a bar graph there. It's taking 190, whatever those time units are. And for the first thing and for the second, it's 340. So, if that's the biggest thing, then I know I need to fix that. Now, that's about 200 to 300. I have here something which is about 30 to 40. It'd be stupid really for me to try to think of optimizing whatever's going on there. Okay, it's a multiply computing buoyancy, right? I'm calling a function called buoyancy, but it looks to me like it's, I don't know, pretty fast. It's fast compared to whatever's happening here. Whatever is happening here is just like lookups. And by the way, I guess I'll tell you that this is, I'm using the S7 object system. That's what the @ sign means. So I don't immediately see a clever way of vectorizing that because of how that's set up. Anyways, keep on scrolling. Maybe I've already found the most expensive. No, I haven't. So this is clearly taking more time. Now we're up in longer bars and 1,000. Maybe I'm just going to scroll the whole thing and see if there's something that's even worse than that. Not seeing. Oh, now I'm in the function, the code that computes depth. Boy, that's fast. I didn't even see anything for that baby. What's this? The one that computes drag. And well, I don't know, a little bit it's squaring something, but those numbers are still small compared to 1,000, right? And this is computing the drag coefficient. Oh yeah, well, this makes sense. That's it's done element by element, so that's taking a little while. Computing the buoyancy, right? And computing the area, which I suspect is just a lookup, so that won't take any time. Or any significant time. Okay, that's good. So let's go back to that big one. So I know that if I want to speed things up, I probably should think about what's happening here. Yeah, and so, I don't see, so we're doing there's no way I'm going to be able to speed up the phi square bracket. That's just a lookup, right? Um, and I don't think that I can vectorize. See this at and this at. I don't really think I can. I think I'm gonna have to do a loop. My guess is anyway, loops are pretty fast in ours, so it's not the loopingness that's the problem. Well, anyway, this is what I need to be thinking of next. This is where the time is being consumed. So there's no reason for me to think about um, other parts of the code, really. There's something uh, about this. To be honest, I'm not willing to go back from the S7 object orientation that I'm using because it would be a lot of coding to do that. And there are some advantages in using an object orientation. Plus, I want to practice how to use S7. And I guess thirdly, S7 is still in rapid development, and it's not unlikely to me that it will just get faster and faster over time. And this is not a video about how to program in S7. So just to show you about profiling. So to summarize, you do library profile and you do profvis, and inside that you have whatever it is that you're computing. And I'm doing this in RStudio because it makes these graphs and things for me. I'm sure there's something clever I could do by moving my mouse in here. No idea what all this stuff is. Maybe I'll move my mouse to, I don't know. I mean, I'm sure this is clever. I don't mean to say that it isn't. Well, that's actually pretty nice. Okay, well, I have more to explore there, don't I? Thanks for watching. I recommend this actually. Take care. Bye.